Have you ever wondered if an integral can be part of an exponent? Well, I've got the perfect problem for you then, and in just a few minutes, you're going to learn how to crush this kind of problem you'll never see in your class. So for this one here, there are two possible solutions for this variable w that we can solve for. One of them is obvious, and I'll tell you later what it is, and you can tell me below if you see it, but let's go ahead and work through this problem here. So we have this exponent e on the right-hand side and a simple constant here on the left. The method I'm going to use to solve this problem is I'm going to take the natural log of both sides, because then on the right hand side, the natural log and the e exponent go away, right? You're just left with this simple integral. And then on the left hand side, the natural log of 1 is really nice. That just becomes 0. So for this right hand side, because I had a sum of terms, I'm actually going to break up that integral into a sum of two separate integrals here. And for each one, I pulled out the constant that you saw in front of the x term. And for each of these now, we need to go ahead and solve those integrals and then eventually find our solutions for w. Okay, so for the next step, this is just simple polynomial integration, right? For x squared, we know that the integral of x squared is 1/3 x cubed plus c. Now I'm dealing with a definite integral here, and the c would normally go away, so we don't need to show it. And I have this pi here in front because I pulled it out. So we're going to evaluate that expression from a lower limit of integration of 0 to this upper limit of integration w that we need to solve for. Now similarly, for the other integral above, we know the integral here of x is going to be 1/2 x squared. And then of course I have this 2 that I had pulled out here in front. And for that, we're also going to evaluate it from 0 to w as well. So moving on, what's really nice here, right? If you remember with definite integrals, you plug in the upper limit of integration minus the expression with the lower limit plugged in. And in both cases, what's really cool is that because the lower limit of integration is a 0, things will simplify quite a bit. As you see here, we have minus 0 in both cases, right? So now when you simplify this further, we now have this new expression of 0 equals pi over 3w cubed plus w squared. And so looking at this, one answer is obvious. And if you see it, let me know below. And before I forget to mention it, if you are finding value in this video and you don't want to miss out on awesome tips for your next exam, be sure to ninja kick that subscribe button as well, because it helps me grow the channel to get you guys more content. So the obvious solution here for w is one case where w equals 0, right? Now it will work because when you integrate from 0 to 0, you will get an area that results in 0. But for this video, let's just stick with the fact that that's too simple of an answer. Let's find the other non-zero value of w. So with that being said, what I'm going to do is, because we're not going to consider w equals 0 as one of our solutions, I'm able to safely now divide both sides by w squared here to simplify our expression even further. In other words, I'm not having to worry about dividing by 0. And so for this, when you solve for w, it looks like a good answer, but there is a little bit of a catch here, right? So